This is episode 3 of Digital Convergence. Today, we're examining how AI systems and global distribution networks create a self-reinforcing loop that progressively narrows cultural expression. In the first 2 episodes, we explored how AI recommenders flatten diversity and how global platforms amplify sameness. Today, we connect these mechanisms into a feedback cycle where homogenized outputs become tomorrow's training inputs, tightening convergence with each iteration. A 2024 study presented at the web conference showed that recommenders reduce inter-user diversity by herding audiences towards similar items rather than expanding individual range. When those convergent consumption patterns feed back into content production decisions, creators adapt to templates that algorithms reward. That adapted content then trains the next generation of models, which recommend even narrower patterns, completing the loop. This isn't about AI collapse from synthetic data contamination. It's about a more fundamental process: how platform incentives, creator economics, and algorithmic learning create reinforcing pressures that systematically narrow cultural expression over time. The loop operates through 3 interconnected stages. First, recommenders push audiences towards similar content, creating winner-take-most dynamics. Second, creators observe what succeeds and adapt their work to fit those patterns. Third, that adapted content becomes the training data for future AI systems, which then produce tools and recommendations that further reinforce the same patterns. Today, we'll examine how this cycle operates in practice, why it's economically rational for individual actors, yet collectively problematic, and how it accelerates cultural convergence across domains. Let's start with how recommender systems shape what audiences consume. A 2024 study presented at the web conference formalized something subtle but critical: the distinction between inter-user diversity and intra-user diversity. Traditional filter bubble concerns focused on individuals trapped in narrow content silos, but the MIT research shows something different happening. Modern recommenders actually reduce filter bubbles by showing users more variety, but it's the same variety shown to everyone else. The study used agent-based simulations to demonstrate that popularity-based and behavior-based recommender systems reduce inter-user diversity, meaning users converge on similar content without meaningfully expanding intra-user diversity or individual range. People across different demographics, locations, and stated preferences increasingly consume similar content. The system successfully expands what each individual sees, but narrows what all individuals collectively encounter. This creates what economists call winner-take-most dynamics. The MIT simulations demonstrate that standard recommenders push consumption toward modal genres, reducing inter-user diversity in ways that stabilize winner-take-most content trajectories over time. Content that gains early traction receives algorithmic amplification across user segments. The system interprets engagement signals as quality indicators and multiplies visibility accordingly. Recent evidence on platform aesthetics shows how popularity-integrated algorithms standardize visual norms. Researchers document phenomena like Instagram face, where algorithmic preferences narrow perceived beauty standards through engagement-driven bias toward sameness. Modest differences in how well content matches algorithmic expectations produce massive disparities in reach. Work that fits proven engagement patterns, specific video lengths, narrative structures, aesthetic styles, emotional arcs, receives exponential visibility advantages over work that doesn't. For creators, this makes algorithmic taste highly visible. Success patterns become obvious through analytics dashboards showing what formats, topics, and styles generate reach. The feedback is immediate, quantified, and economically consequential. Meet Sophia, a digital artist creating work rooted in her cultural background. She posts regularly, but the platform consistently labels her distinctive style as niche content, limiting its distribution. Meanwhile, she watches posts using mainstream aesthetics, the kind she sees everywhere in her feed, achieve dramatically higher reach. Her analytics dashboard makes the trade-off painfully clear. posts adapted toward platform-friendly aesthetics receive 10x the visibility of her culturally specific work. Comments increase, follower growth accelerates, and monetization opportunities multiply. But only when she moves toward the aesthetic center of gravity the algorithm recognizes. This isn't about quality. Sophia's distinctive work is sophisticated and skilled, but exploratory content becomes an economic risk when visibility operates through algorithmic gatekeeping. The rational choice, given income dependence on reach metrics, is incremental adaptation toward proven patterns. Now let's examine why creators adapt their work to fit algorithmic preferences, even when they recognize the cultural costs. The creator economy operates on attention metrics. Visibility converts directly to income through advertising revenue, sponsorship deals, product sales, and platform monetization programs. When algorithmic systems control visibility distribution, their preferences become economic imperatives. Recent scholarship connects this to what researchers call creative precarity, where the roles, rights, and identities of cultural workers grow more uncertain amid platformized metrics and automated content pipelines. A 2024 study by Haikayang Lee documents how generative AI reconfigures creative roles, weakens control over copyrighted works, and shifts audience perceptions of authenticity, compounding platform capitalism's effects on cultural labor. Research from King's College London similarly warns that rising precarity pushes artists to realign practices under algorithmic and market pressures, transforming cultural work into content optimized for engagement metrics rather than cultural meaning. Consider how AI tools themselves participate in this adaptation process. By 2026, creators routinely use AI to analyze successful content, generate ideas, and optimize positioning. Marco, a filmmaker, runs AI analyses on winning films and receives templated arcs and visual suggestions that mirror engagement histories. He recognizes immediately what's happening. The tool isn't optimizing for originality or artistic merit. It's optimizing for patterns proven to generate engagement in past data. Those patterns reflect what algorithms previously amplified, creating a feedback loop where past algorithmic preferences shape future creative decisions. Marco tweaks his pitch to align, trading distinct vision for predictable reach. This is economically rational. The modified version will likely achieve better visibility, reach larger audiences, and generate more income. But the collective effect is cultural. As more teams follow this path, training signals increasingly normalize those same patterns. This produces homogenization through three connected mechanisms. First, template optimization. AI tools trained on platform data identify patterns associated with high engagement. Those patterns reflect previous algorithmic amplification, not necessarily creative merit or cultural value. Second, economic rationality. When visibility directly determines income, creators face strong incentives to adopt templates that reduce algorithmic friction. Cultural specificity becomes a luxury requiring economic security to maintain. Third, training feedback. As creators adapt their work, that adapted content enters training datasets for future AI systems. Next-generation tools become even better at recommending proven patterns and, worse, at supporting cultural diversity. The result is what researchers call infrastructural homogenization. The systems don't explicitly enforce standards, but their economic incentives and technical operations create powerful pressures toward convergence around algorithmically legible formats. Now we reach the critical feedback mechanism: how today's homogenized content shapes tomorrow's AI capabilities. AI models learn from data. When that data increasingly consists of content shaped by algorithmic preferences, models inherit those same preferences. They don't learn the full range of human cultural expression. They learn the subset that survived algorithmic filtering and creator economic adaptation. This compounds existing biases. A 2024 analysis reveals striking linguistic imbalances. LLaMA2's pre-training corpus contains roughly 89.7% English, while GPT-3 estimates sit around 92.65% English tokens. These measurements illustrate the scale of linguistic concentration in widely used systems, systematically advantaging English and high-resource contexts while underrepresenting the majority of the world's languages. When new training data is further filtered through platform algorithms that favor globally legible patterns, future models become even less capable of recognizing cultural specificity. The linguistic and cultural imbalances encode socioeconomic and geographic asymmetries directly into model behaviors. Let's walk through a concrete example from 2029. Streaming platforms use AI-generated success scores to make greenlighting decisions. The models analyze engagement patterns from previous content to predict what will succeed. The result is productions that share similar arcs, pacing, and visual styles, all optimized for retention metrics. These shows receive algorithmic promotion across user segments. The WWW 2024 study simulation results help explain what happens next. As recommenders push consumption toward modal genres, this reduces interuser diversity in ways that stabilize winner-take-most content trajectories over time. Viewer tastes gradually bend toward what's consistently offered, since exposure shapes preference formation. When platforms analyze viewer behavior, they interpret consumption of algorithmically promoted content as authentic demand. The system registers success for the formats it already selected, completing a circular validation loop. Novel formats appear risky because models haven't encountered sufficient training examples to predict their success. The algorithmic infrastructure makes safe bets safer and experimental work riskier, regardless of actual creative merit or potential audience interest. Audiences participate in this loop, usually unknowingly. Research shows users rate culturally unfamiliar content approximately 22% lower on average, not because it's objectively inferior, but because algorithmic curation has trained expectations for certain patterns. When traditional forms or culturally specific expression appears in feeds, cognitive unfamiliarity registers as quality deficiency. Users scroll past content that doesn't match learned patterns, generating engagement signals that tell the algorithm this content underperforms. The system interprets these signals as confirmation that culturally specific content is lower quality, further deprioritizing it in recommendations and training datasets. Individual consumption choices, shaped by algorithmic prior exposure, create feedback that narrows future algorithmic choices. The cycle accelerates because multiple economic forces reinforce each other. The creator economy, valued at $250 billion and projected to double by 2027, demands AI-assisted production for competitive viability. Platform capitalism optimizes for engagement metrics, making virality-aligned formats more economically valuable than culturally significant work. Formula-friendly content becomes cheaper to produce with AI assistance and easier to promote through algorithmic systems. Resource-constrained creative teams face rational incentives to chase algorithmic fit, even when they recognize long-term cultural costs. Individual adaptation strategies that make economic sense create collective cultural dynamics that narrow future possibilities. The vicious cycle operates through individually rational choices that produce collectively problematic outcomes. Each actor, platform, creator, consumer makes reasonable decisions within their immediate constraints. But those decisions interact to create systemic effects that narrow cultural possibilities over time. Platforms optimize engagement to maximize revenue. Creators adapt to algorithmic preferences for economic survival. Consumers engage with familiar patterns shaped by prior algorithmic exposure. None of these choices alone causes homogenization, but their interaction creates powerful convergent pressures. This is what makes the cycle difficult to address. There's no single villain or obvious intervention point. The narrowing emerges from how economic incentives, technical architectures, and behavioral patterns reinforce each other across the system. The implications extend beyond cultural heritage to innovation capacity itself. A September 2024 study published in PNAS Nexus conducted a comprehensive cultural alignment audit of 5 consecutive GPT models: GPT-3, 3.5 Turbo, 4, 4 Turbo, and 4.0 across 107 countries and territories. The researchers compared model responses to nationally representative world values survey data and found all models exhibit cultural values resembling English-speaking and Protestant European countries. Specifically, GPT-4o's outputs were closest to Finland, Andorra, and the Netherlands, while most distant from Jordan, Libya, and Ghana. The study revealed something critical. Models are oriented toward self-expression values, including environmental protection and tolerance of diversity, which are commonly found in Western contexts, but don't match traditional values prevalent in many other societies. The researchers tested cultural prompting, asking models to respond as someone from a specific country, which improved cultural alignment for 71% to 81% of countries in recent models, though it remained ineffective or even counterproductive for some European countries where default alignment was already close. When model outputs reflect culturally skewed defaults, downstream creative and analytical tools risk channeling problem framing and stylistic choices into narrower grooves. If institutions increasingly lean on similarly aligned models and recommenders, solution search contracts around shared Western value frameworks and reasoning styles, raising what researchers call systemic monoculture risk. The WWW 2024 results support this concern. When successful recommenders converge users on the same content clusters, this creates structural pressure that can analogously narrow methodological variety in adjacent decision systems. The cycle reduces not just what gets created today, but what becomes imaginable to AI-assisted creators tomorrow. The vicious cycle between AI and globalism represents a system dynamic rather than a conspiracy or simple cause-and-effect relationship. Homogenization emerges from how recommender algorithms, creator economics, and consumption patterns interact to create self-reinforcing pressures toward convergence. No single actor intends to eliminate cultural diversity. Platforms optimize for engagement, creators pursue economic survival, and consumers follow preferences shaped by their curated exposure. But these individually reasonable choices produce collectively concerning outcomes when they reinforce each other through feedback loops. Understanding these mechanisms doesn't immediately solve them, but it creates possibility for different choices. When we recognize how today's adaptations shape tomorrow's training data, we can begin asking what those adaptive pressures cost and whether alternative arrangements might preserve more cultural variation. This has been Digital Convergence. Today, we examined how AI recommendations, creator adaptation, and consumption patterns create a self-reinforcing cycle that progressively narrows cultural expression through interconnected feedback mechanisms. Next time, we'll explore how this cultural convergence affects innovation capacity itself. Why homogenization isn't just about losing heritage, but about constraining the solution space for problems we haven't yet encountered. When institutions converge on similarly aligned models and metrics, problem-solving search contracts around shared priors, creating what researchers call monoculture risk. The feedback loop operates with mathematical consistency regardless of individual intentions. Understanding it reveals both why convergence happens and where intervention points might exist.